All right, insurance pricing agent, time for the second central moment, the variance. The formula for the variance is very similar to what we did with the mean, and that's going to help us when we're creating our spreadsheet together. What we do is, whereas before we took each value of our random variable, we multiplied it by its probability, and we added them together. Well, we're doing something pretty close. We are adding a bunch of things together. We are multiplying each of those things by their probability. It's just what we're adding. Instead of adding the random variables themselves, we are adding the squared deviations of those random variables from the mean. We take the random variable, we subtract out the mean, so the deviation, and then we square those deviations. And then from there, it's the same old multiply across and add down. Let's go have a look. Now, in the first part of your exercise, you went in and played with the actual outcomes, like what are the losses and profits and what are the associated probabilities. So that's done. You shouldn't do that over here. That's already kind of locked in. What you need to do is to calculate the variance first and then take the square root of that variance to come up with the standard deviation. So all of these pieces are kind of in play, they're in weight, and you have an expected profit, and we've named that cell expected P or expected profit of $3,500, at least is the numbers that we have in here, every time that you sell a new policy. So what you have to do first is you have to calculate the individual deviation. So suppose this is the scenario that plays out. How far off is that? Well, it turns out that we take I3 minus expected profit and we get negative 500, 3,500, and so on down the road as you go down this column. That's the first thing that you need to do. From there, column M just squares all the values in column L. So you can see just L3 squared, L4 squared, L5 squared. These are the squared deviations. And then lastly, remember we need to multiply each squared deviations by the probability of that random variable taking on of the value that it does. So what we do is we multiply this value by, say, 1.5%. We multiply this squared deviation by 1% and this squared deviation by 0.5%. And now we have multiplied across, we've multiplied our squared deviations by their probabilities, and we add down. And once again, we've created the variance associated with loss, the break-even variance, and the gain variance for a total variance of 7.4 billion. So that's quite a high number, but what we tend to work with as mere mortals is not variance, but standard deviation, which is just the square root of the variance. So down here, we have equals square root of the variance, N24, and we come up with a value of 86,100. So we want you to go in and calculate these things yourself. We're going to blank it out and just watch this video to get a sense of what's going on. From a practical standpoint, you might ask yourself, well, that's a lot of variance. That's a lot of variation in terms of what can happen to me as the seller of these policies. And it might cause you to ask, am I charging enough for this insurance? Maybe you are, but maybe you're not. And so that's where we're going to leave it for now, and we'll move on to the third moment.